So students, let us see a visual proof of what we just studied. Okay, this might you'll have to concentrate a lot in this to understand how it is being done. Okay, so look carefully and give me your undivided attention. Okay,
Video is sponsored by Brilliant. Let's say we have a 2 to the n by 2 to the n grid where n
okay.
is
So imagine that you have a 2 to the power n into 2 to the power n square. So the area of the square is 2 to the power n into 2 to the power n. Okay, this is a square. 2 to the power n is a length, so it could be any number. 2 to the power 1, 2, 2 to the power 2, 4, 2 to the power 3, 8 into 8, 2 to the power 4, 16 into 16. So you get it. It could be any number. Okay, it's a variable. So just imagine this is our case. Okay, 2 to the power n into 2 to the power n square. So it could be
greater than or equal to 1. So this could be a 2 by 2 grid,
maybe 2 by 2
4
or
by
4 by 4
8
or
by
8 by 8. You get
256
it.
by 256 or whatever. The question is,
It
can
could
you
be
tile any of these
now.
entire
It could be any type of square. Now the question is whether can you cover
grids except
all
for
this.
one square, and that could
You can cover all these squares except one square. Okay, except one square, any one square, except any one square. Can you cover all the other squares with
be
only
any square using only L-shaped tiles
L-shaped
that cover 3
L-shaped, squares? For
spots
example, like
total.
this. See,
This would not be
using only L-shaped squares, is it possible for you to cover everything in every part of this square except one square? Is that possible or not? Using only L type of shapes. Okay, that is what we need to check. You could use how much ever L shapes you want, but using only L shapes, you should be able to cover the whole thing. Now that is what you're going to check. So this we are going to do by the principle of mathematical induction method. So first we'll start with the base case.
so n
That is the
equals 1
first
here
case. Step 1, test.
corresponds to a 2 to the 1 by
N is equal to 1. That is 2 to the power n was the length, right? So n is equal to 1 means it is 2 into 2. So 2 into 2. The total area of the square is 2 into 2. 2 by 2 square.
2
So
to the 1 grid. And it's easy to see this can be tiled with L-shaped tiles besides one square. If I want this square to be the untiled
if I want this square to be the uncovered square, so I can
one,
put a
then
L
we just
shape
do
here.
this.
See?
If I want this square
If I
to be
want
the one
this-
left open, then we rotate the tile as shown. And we can do the same
If I
thing
want
for the
this-
other two.
So you see that it is always possible for me to cover all the squares except one with a L shape. You see that?
So
So-
I can tile this entire thing but leave any one square open. We now know this works for a 2 by 2 grid or n equals 1.
So
Now-
we got an observation. What is our observation? This thing is true for n is equal to 1. Okay.
Now we just got to prove it for every other integer value of n. The second step, though, is what confused me for a while. What you do is assume that our statement
Okay. Now
is
what we are going to do here is, so our first step is over. Now second step of our principle of mathematical induction is, we are going to assume that it is possible for some value of n, n is equal to k. Okay, but n is equal to k, I cannot, or we cannot show in the screen, show in the computer. We need some value. So because of that, I am assuming k to be 2. So it is 2 to the power n, right? The length of the square is 2 to the power n. So here it is n is equal to 2. So 2 to the power 2 is 4. Length is 4 by 4. So 4 into 4. So 4 square is the length. Okay, 4 into 4. It is that type of a square. So here we are going to assume. Second step is assume, right? So second step we are going to assume that it is true. For n is equal to 2 or some value. In this case we took n is equal to 2. You could take some other value. Okay.
true for any n. I'm putting a 4 by 4 on the screen specifically just to help with the visuals, but no,
It is 2
formally
to the power n into 2 to the power n. You could use any number only to show you. We took as an example n is equal to 2. Okay.
just assume this is the case with any n. So for our example, we assume any 2 to the n by 2 to the n grid besides one square can be tiled, even though we have no idea if that's true. And then we have to prove that this implies we can do it for the n plus 1 case.
So what is the next step? The third step is using the facts that we have now, our observation and our conclusion. Using these things, we need to prove that it is true for n is equal to k plus 1, right? Our k was 2, n is equal to 2, that was our case. So k plus 1 will be n is equal to 2 plus 1, 3. So n is equal to 3. So 2 to the power n plus 1, our n was 2. So 2 to the power n plus 1 is 2 to the power 3, that is 8. 2 to the power 3, that is 8. So it is 8 by 8 square. Now look carefully. We need to prove that we can cover all the squares in this 8 by 8 square except one by only using L-shaped squares. Okay?
Case, or the next largest case. If I can do it with a 4x4, can I do it with an 8x8?
So,
or if I can do it with an 8x8, can I do it with a 16x16, and so on?
So suppose your n is equal to k. Suppose your n is equal to k was 8 by 8, you chose k is equal to 3, then this would be a k plus 1. So you get it.
We have to essentially prove all of these at once. So I'm going to stick to the 4x4, and we're saying it can be tiled
So
completely
this we are
besides
assuming
any
that
one
it is
square.
true. We are assuming.
But does this mean we can do it with an 8x8?
So we are assuming that yes, we can cover all the squares of 4 by 4 without except one. That we have already assumed. But how can you prove for 8 by 8?
Well, all we have to do is split that into 4 quadrants to get
So
four
what I'm
different.
going to do, see, I'm going to divide this 8 by 8 square into 4 squares. It is possible, right? Just cut it into 4 pieces.
4x4 grids.
So it is a 4 by 4
From
square.
the assumption, we can say
When each square is 4 by 4. 1, 2, 3, 4. 4 by 1, 2, 3, 4. 4. 4 by 4 squares. Each of these squares are 4 by 4 squares now.
this grid on the top left can be complete.
So you see, I know that it is true for 4 by 4. That was my assumption. So this is a 4 by 4 square. So it is true for this square. Okay.
Completely tiled besides any one square, like the bottom right. This other grid can be tiled besides any one as well.
See, this is a 4 by 4 square. So I can prove it for this square also.
We'll say the bottom left. And this one can be tiled completely
This is a 4 by 4
besides any
square.
one, like
I can prove it for this square also.
the top
And
right. Then this last one I'll keep a random square as the untiled
see?
one. And I did
all these are 4 by, when I cut it into 4 pieces, I got 4 by 4 squares. That means I already assumed it is true for 4 by 4 square. That it is possible to cover all the squares without except one square. We assume that it is possible. So 8 by 8 square, I cut it into 4 pieces. So I got 4 by 4 squares like this. And because I assumed it is true, I could say that all these 4 pieces I can do, right? Now,
it this way because since this can be achieved with L-shaped tiles based on our assumption, then one more here completes
now
our
I only
task
have
of
an L
tiling
shape
all
to
but one square.
cover. Do you see that? I only have a L shape here and this square. So if I can put a L shape
Based on our
here,
assumption, then one more here completes our task of
See?
tiling all
so you covered everything except one square in 8 by 8.
but one square. This works for any blank spot though.
So do you see
If
that?
I wanted this to be the untiled
Suppose
one,
you wanted
then
this
we
to
could
be
just
the
use the 4x4s to complete
uncovered
the
one.
other
So
three
you can just put
quadrants
a L
as
here.
shown, and then fill in the middle again. So we've shown that if a 4x4 grid
So what did you see?
can be tiled,
We saw that we assumed this is 4 by 4, it is true. It is possible to do with 4 by 4. Now because we assumed it is possible to do with 4 by 4,
as we want,
we
then
proved
8x8 can as well. But this keeps going.
that it is possible for 8 by 8. Do you see that, students? This is the principle of mathematical induction. Now suppose what you chose, n is equal to k. Suppose what you chose was an 8 by 8.
Because if this works with an 8x8, then it works with a 16x16.
Then that you could divide
by
into
just
16
splitting
by
it up into
16.
quadrants
You could
and
divide into
filling
4
in the middle
pieces.
spaces
And
like
that will
4.
also be
And
applicable
going down,
for
if a 2
32 by 32. You can keep going. So you saw that your
by 2 grid
observation.
can be tiled as we want.
So you saw that you had an observation. Based on this observation, you made an assumption, assumed something. And with that observation and assumption, with both these things, you deducted something or you proved something. Now that is your principle of mathematical induction. Now that was the visual proof of what we just did. Okay, thank you students for watching.